In this video, I want to walk through two examples of writing absolute value functions when we're given a vertex and some other point that the graph of the function passes through. Well, here's the general form for our absolute value function. F of x equals a times the absolute value of x minus h plus k. And a little reminder also that the vertex is given by the ordered pair hk. Okay, well, if we're given the vertex, and the vertex are the h and k values, it looks like, as far as this back end is concerned, we're totally taken care of. So our concern is this a value. How can we find it, and what does it mean, that kind of thing. So let's go ahead and write what we know so far. F of x equals, and I'll leave a little blank here for our a value. We're not sure what that is yet. But we have the absolute value of x minus h, which is the x coordinate of our vertex, so that's negative 1. And then outside the absolute value bars is our plus k, and that's our y coordinate from our vertex, so negative 4. And of course, we'll end up going swoosh swoosh right here, and that'll be x plus 1 when we're all done with this. So, okay, what does this a value represent, and how can we find it? Well, the a value plays a couple of roles. If a is negative, then we know the graph of the function has been reflected over the x-axis, and it will open downward. If a is positive, then it's going to go ahead and open upward. And of course, when you have a downward opening absolute value graph, the highest point, this maximum here, is going to be the vertex. And similarly, when it's opening upward, this lowest point is going to be the minimum, and that's the vertex. So that's good for us, because we just need to decide, is this point P, is this above, or is this below the vertex? Because that will tell us then whether it's opening up or down. Well, we'll look at the y value to help us know whether it's above or below. So for the vertex, the y value is negative 4. For this other point, the y value is 0. Well, 0 is larger than negative 4, so this point P is going to be above this vertex. So it's going to be this way. So the vertex is a minimum, which means it's opening upwards, and a, in this case, is greater than 0. So it'll be positive. So the other thing that we need to get from this a value then is the slopes of these lines. And that's kind of, has the function been horizontally compressed or stretched, or is it just kind of right in line with the parent graph? Okay, well, the way we can figure that is by using our slope formula, which says the change in y over the change in x will give us the slope. So let's go ahead and use that. So the change in y, 0 minus a negative 4, divided by the change in x, 3 minus a negative 1. So this will end up being swoosh swoosh, 0 plus 4 is 4, a little swoosh swoosh, and 3 plus 1 is 4. So our slope is 1, which means that there has been no horizontal compression or stretch, because this slope here is 1, which is the same as our parent graph. So we know that a then is positive, and we know it's 1. So if it's positive 1, then we actually don't need to write it here at all, because when the coefficient is just 1, especially positive, we don't need to write anything. So to finish up our function, f of x equals, and this is just positive 1, so we'll write absolute value of x plus 1 minus 4. And this function right here, it's an absolute value function, and it's the function whose vertex is negative 1, negative 4, and it also passes through point P, this ordered pair 3, 0. In the second and final example that we're going to look at, we're given the vertex as the ordered pair 2, 5, and the other point that the graph of this absolute value function passes through is 0, negative 1. Okay, so we know once again that the general form of an absolute value function is going to be like this, and we also know the vertex is hk. Well, we're given the vertex, so we know h equals 2, and k equals 5. So once again, we can just go ahead and plug those values in. So x minus 2 plus 5. So once again, we'll put this blank here. We're not really sure what a is quite yet. So in the previous example, we said that a is positive when the graph opens up and the vertex is a minimum. And A is negative when the graph opens down and the vertex is a maximum. So we just need to kind of look at these y values and decide which one's higher than the other. Well, if our vertex has a y value of 5 and our other point has a y value of -1, well, -1 is definitely lower than 5. So if our vertex is higher, then that means our vertex is a max, and we know our A value is less than 0. So we'll have a negative out front here whenever it's said and done. And finally, the other piece that we need is the slope, because that will be the slope of these two legs. And so let's go ahead and do it. So our slope formula says it's the change in y over the change in x from these ordered pairs. So we have -1 minus 5 over, and we have 0 minus 2. So -6 over -2 equals 3. So that's going to be the slopes then of those legs. So we'll just put that 3 right in there. Okay, so let's kind of write this a little nicer. F of x equals, okay, we have our -3 times the absolute value of x minus 2 plus 5. And this function here is the absolute value function, whose vertex is given to us here, the ordered pair 2, 5. But the graph of the function also passes through point P, this ordered pair 0, -1. So those are some things you need to take into consideration when you're writing an absolute value function and you're given the vertex and some other point that the graph of the function passes through.